The purpose of this video is to solve simultaneous equations using matrix method. The students have suffered seriously, and they have seriously suffered because one, they do not know how to multiply matrices, 2 by 2 matrix. Then two, they don't know how to calculate the inverse of a 2 by 2 matrix. So I want to begin with the multiplication of a 2 by 2 matrix. So this is a matrix multiplication. When you multiply two matrices, this matrix here and this one here, to multiply them is very easy. What you need to do, is to multiply a row in the first matrix with a column in the second matrix, and you sum up the elements. So here, carry a paper and then cover here. When you have covered there, for example, this is A, this is B, this is C, this is G, for example, like this, this is E, this is this is E, this is C, this is A, this is F here, this is G, this is H, this is I, this is J, and this is K, like this. What you need to do, you cover here. You have covered here like this. You multiply this element with this row downward this way. So A multiplied by F plus B multiplied by G, which is shown here in the first element. You do like that. You do like that here. Do like that here. When you are through, you could have written all the elements above. What I mean is A multiplied by H plus B multiplied by I. A multiplied by J plus B multiplied by K. When you are through, you place this one up like this, you cover this one, you multiply this way, like when you're going down, multiply like that, going down, multiply like that, going down, and you get your matrix there as easy as that. When you have done that, then you are now able to move on and do matrix multiplication in the solution of simultaneous equations. Now, next is the inverse of a 2 by 2 matrix. The inverse of a 2 by 2 matrix is easy. The first step of the inverse of a 2 by 2 matrix is to calculate the determinant. So, if we have A equals to A, B, C, and D, you need a determinant. So determinant equals to, you multiply the leading diagonal, and that means A multiplied by D minus C multiplied by B. Then A inverse equals to 1 over determinant, this one here, AD minus CD, then you interchange the leading diagonal. You interchange this and this. This is D, this is A. Then you negativate the two. You negativate C and negativate B. That is the inverse. When you know this is applicable in the simultaneous equations. So let us use the multiplication matrices and the inverse of a 2 by 2 matrix to calculate, to solve a simultaneous equation that is seen on the Y. So a solution of 5x plus 2y equals to 12 and 3x plus y equals to 7 is easy when you use matrices and even using elimination. How? Because one thing that you need to do is to form a coefficient matrix. Formation of coefficient matrix is none other than writing this number here, this sign and this number, this one, and this is 1 here. When you have written that, you will write it as a 5 coefficient matrix, 2, 3, and then 1 like this. Then you write x, then y, like this, and then this is equal to 12, then 7, like this, like this. When you have written that, you have done halfway work. You have done halfway work. Then what you need is to remove this matrix from here. And to remove this matrix from here, you multiply both sides by the inverse of this matrix. So the inverse of this matrix, A inverse, that's why we did inverse equals to, you multiply this, multiply by that one, 1 over 5 multiplied by 1 is 5, minus 3 multiplied by this is 6. That means 5 minus 6 is -1. Into interchange 1 and 5, and then -83 and -82. That is the inverse. Use this inverse here, and place it inside here. Use this inverse here, and place it here, and multiply it, and multiply here, and multiply here. When you do that, here, the answer, when you multiply this one multiplied by this, the answer is 1. So you remain with the x and y like this, and then you multiply this one, -1 into 1, -3, -2, 5, and then 12, 7, like this. First, multiply this. First, multiply that one. Multiply this. First, multiply this before you multiply with the determinant here. Before you use this determinant, work out this one. So we can be able to sit down there already have done it. Let us move down and see how we've done it. You see, I have multiplied here by the inverse, and I have said do not work out this. Why? Simply because the answer here is 1. When you are very careful in calculating the inverse. So work out this one, but first of all work this, then you multiply by this scalar. So you can be able to see, I have closed it like this. I have multiplied 1 times 12 in 12, and -2 times 7 in -14. So 12 u plus -14, the answer is -2, which is this one. Then you close up here like this, you multiply this with this column, multiply this row, this multiply by this in -36, this multiply by this in the 35. When you -36, you plus 35, the answer is -1. So this one operates here, and this one operates here to have positives only, and so therefore x is 2 and the y is 1. As easy as that, so easy as that. Let us see example 2. Let us look at example 2. So example 2, the simultaneous equation is 3a plus 2b, the answer is 12. 4a minus b, the answer is 5. The coefficient matrix is 3, 2, 4, -1, a, b, then the answer is 12, 5. Move down. So this is the coefficient matrix. The inverse of this one is 3 multiplied by -1, which is -3, minus 8, -11, which is here, into, you interchange this and this, they have interchanged, and then negative to the 2, negative to this and this, they have done the same, and then we multiply both sides by A inverse. We multiply here by this inverse, and here by this inverse. When you have done that, then you work out. Do not work out this one because you waste time. Move and work out here. And when you are working out here, please work this fast. And this is why I have bracketed like that. Work out this one, close like this, multiply like this, close like this, multiply like that, and the answer is -22 and -33. So when you work out this one and this one, it is 2, and this one down here, it is 3. So the answer is A equals to 2, A equals to 2, and B is 3. Those are the answers. Let me move to give you an exercise so that when you are there, you work alone. So the exercise, the questions are there. I use Matrices method to work out all of this. And when you have worked out all this using the examples above, the workings above, you will be experts and you may not be able to look for substitution, look for elimination of graphical. You will only be very happy when you see matrix method. Thank you so much and thank you for watching me. This is Mr. Opare.